Since the way I'm going to do this question is going to be new to many people, I'm going to explain my way of thinking using a simpler example that I'm going to create out of this question. So this is a simpler example. So in this I have reduced the number of experiences from 3 to 2. So in this case we have sweaty palms and we have dizziness, but we don't have vomiting. So we have 300 subjects who are going to experience at least one of these effects, and out of these people 40% experience sweaty palms and 75% experience dizziness. Now my question here is it possible that nobody experienced both sweaty palms and dizziness given these data points? I would want you to think about this question before you listen to my answer. If you want to pause the video, you can pause the video. The answer is that it is not possible that nobody experienced both sweaty palms and dizziness. Why? Because the total of this, people who experience sweaty palms and people who experience dizziness, is more than 100. Right? Now if there was nobody who experienced both of these things, and essentially the people who experience sweaty palms are different from people who experience dizziness, right? They are unique. Then the total of these two has to be equal to the total number of people out there, right? Which is 100%. But since the total is coming out to be greater than 100%, there has to be some people who have been double counted, right? Who have been counted both in sweaty palms and in dizziness. Now the question is, how many people were double counted given this data point? Again, think about it. We see that the sum of these two numbers is 115%, right? If there were no overlap between these two sets, then what would be the total? Then the total would be 100%, right? Essentially 100% is the total number of people out there. So if there is no overlap, then all the individuals in these two sets are unique, and the total of these two sets has to be equal to the total number of individuals out there. So if there was nothing common between these two sets, then the sum of these two would be equal to 100. But we realize that the sum of these two is more than 100. So there has to be something common. Now the question is, how many people are common, or how many people experience both of these effects? The answer is, again we can see that 115 minus 100%. So we see that 15% people are extra here, right? So these many people must have been double counted. That's why there is an extra 15% we have, right? There is no other reason why there has to be an extra 15% in the total. This must be the double counting. So which means that 15% of the people experience both dizziness and sweaty palms, right? And since we are looking for people who experienced only one of these effects, so since 15% experienced both, people who experience only one of these effects has to be 100% minus 15%, which is 85%, and then you can multiply it with 300 to get the number of people. Does this make sense? Now I can take any other numbers here, actually, not just 115. So let's say if the sweaty palms were 55 and dizziness were 60, or let's say 65, then we can see the total is 120%. So now I can easily say that people who experience both of these effects has to be 20%, which is 120 minus 100%. Okay, I'm doing all of these calculations keeping this in mind, that all of the subjects experience at least one of these effects. Okay, which means that if I count the total of these two, the total has to be 100%. And since there is double counting, I'm getting more than 100% when I'm summing them up. Does the concept make sense? Now let's say there are 3 variables instead of 2. Okay, let's say there is SP and then D, and let's say there is vomiting also, and I tell you that this is some numbers, let's say 40%, 50%, 60%. Now again the total is greater than 100%, right? So there must have been some double counting. Now in this case, since there are 3 sets, that could be triple counting also, since there could be people who experience all 3 of these effects, right? Now in case of such people, they have been counted thrice. Ideally they should have been counted once, right? So those people have been counted 2 times more than they should have been counted, right? So let's say I tell you that people who experienced 2 of these effects, any 2 of these effects, is let's say 10%. So we can see the total of these 3 is 40 plus 50, 150%, and I have told you that double counting is 10%. So I can subtract 10% from here to get 140%, right? Now still it's more than 100%, so there must have been some triple counting as well. So how many people were triple counted? So we can see that the excess here is 40%, right? So 140 minus 100%. So the excess number of people we have here is 40%. And these are accounted by people who have been triple counted. And triple counted, again, people who should have been counted once, but they have been counted 2 more times. So let's say the number of percentage of those people is X. So this excess must be equal to 2x, because these X percentage of people has been counted 2 times more. So they have been counted twice in excess, right? So we can see that 2x must be equal to 40. That means x equals to 20. So in this case, the number of people who have been triple counted has to be 20%. Does this make sense? If yes, let's go back to our original question. So it says 300 people are there. 40% experience sweaty palms. So sweaty palms is 40. Vomiting is 30. And dizziness is 75. So again we can see the total is greater than 100. So the total is 145. And all of these subjects experienced at least one of these effects. So the total unique should have been 100. So there is a excess of 45%, right? And 35% of these subjects experience exactly 2 of these effects. So 35% people were counted twice. They should have been counted once. So there is an excess of 35 here. So we still have excess of 10% left, which must be accounted for by people who have been counted thrice, right? So let's say X is the number of people, or X is the percentage of people who have been counted thrice. So this 10% must be equal to 2x, because they have been counted 2 times more than they should have been, right? So there is an excess of 2x there. So 2x must be equal to 10%. So x must be equal to 5%. 5% people have been counted thrice. 35% people have been counted twice. So how many people were counted just once? So 100 minus 35 minus 5, which is 60%. So how many of the subjects experience only one of these effects? 60% into 300, which is 180. So that is the answer. Does this make sense? If you have any doubts, please feel free to ask.